So this answers the standard. I can solve a complex circuit given one of the currents. And this is chapter 26, problem 62. And it reads, through what EMF, or what must the EMF E in the figure which I recreated be in order for the current through the 7 ohm resistor to be 1.8 amps? Each EMF source has a negligible internal resistance. So I think this is going to be kind of hard to explain since you didn't get to see me work through it, but I'm going to try to remember how I solved it and talk through it. So I started with the loop rule and the junction rule, where the algebraic sum of potential differences around in the loop must be 0. Careful use of consistent sign. Oh, and the currents at eddy junction must be 0. Those are the two rules that I used. So in the first thing that I did was I said that over here on the right, I think you can see my mouse. So I said this was 1.8 amps down through the 7 rooms. So I said this whole loop had to sum to be, that's not where I started. Okay, I started over here, down in this line of thought. So I said this loop had to sum to be equal 0 in volts. So here with the 24 volt battery, and I think I just arbitrarily guessed that it was going this way, and I'm sure it ended up being right. I don't think I switched direction. So I said the 24 volts going this way, well, it's going to be equal to everything else, but I subtracted over it, is equal to the 12.6 volts. Where did I get that? 12.6 is 1.8 amps times 7.0 ohms. Oh, okay, so I must have started over here. So I said the 1.8 amps was going down here, so it had to be going this way as well. Hold up, that can't be right. Okay, so I confused myself, but I think I'm back on the right track. So this voltage from the battery up here has to add with the other differences in this loop to equal 0. So we know that the current through this resistor yields 12.6 volts heading that way, and we know that there's some current heading towards, that's what I was doing. So I was trying to find the current, not over here, I was trying to find the current that was heading this way, because I knew that it would, because the junction rule was going to split this way, and to do that I did the loop rule, because I knew that I could sum everything equal to 0. So 24 minus the 12.6, which I got from over here, minus, I called this IA for no reason, I don't think. Maybe I should have used a number because A in amps. Regardless, this is IA multiplied by the 3 ohm resistor, because this would be the same current going this way and this way, since it's a resistor here. And this is going to add this way. Now I'm confused. Why is this 12.6 here? Okay, I figured out what I was doing wrong. I didn't do this loop first. I did the whole thing around first. In that case, there's this 24 difference. There's this current that's going through this resistor, and then there's a current going through this resistor. And those two are differences. That makes more sense. I was trying to figure out how this was connected over here, but it's not. It's this whole big square. Okay, so that's why 24 minus the 12.6, which is the current through this resistor here, times some unknown, or plus minus some unknown current through this resistor here, which yields IA, or current A, to be 3.8 amps. Then using the junction rule, I know this is 1.8 over here, this is 3.8 here, that means 2 amps has to be going this way. So after, I think I did that math right down here. So if it's 2 amps going this way through a 2 ohm resistor, that's a difference of 4 volts. And over here then, if we were to look at this smaller loop, I think is what I was doing. This math down here. Okay, I think I looked at this smaller loop here now. And I'm going to do a similar thing with the loop. So I know that this E is going to produce some voltage V, and then I know that this current is going through this resistor, which is this number down here. And I also know that there's now 2 amps going through this 2 ohm resistor. But this is working that way. Okay, that's why there's a plus sign here. It's because it's going in the opposite direction. That's right, because this is trying to go this way, and it's going that way because this is splitting up. So I said V minus the voltage difference from here, and the voltage added to the voltage difference here has to be equal to 0. Which means the voltage of this battery has to be 8.6, which is E is 8.6 volts. Ah, okay. Now that I'm looking at it, I think it would have been just as easy to do a loop law over here. I don't think there was any reason they had to do it over here. I just want to make that clear that I think that you can do it both ways.